Work it, make it, do it, makes us.
All right, good afternoon. Last session of the day, almost there. Excellent. My name is Arun Gupta. I work for Amazon Web Services. Today I'll talk about how do you deploy your microservice using 4 components, AWS S3, API Gateway, Lambda, which is our serverless offering, and Couchbase. As an individual, I am a Docker captain. I've been talking about containers for a while. I'm also a Java champion. I've been speaking at lots of different conferences around the world for a number of years. Let's jump right away. This is a definition given by Martin Fowler in terms of, wait, what is this thing here? Okay, that's not part of my slide. All right, this is a definition that was given by Martin Fowler for microservices. A lot of vendors have adopted the definition per their taste. But if we look at it in a very small way, it's basically you take a big monolith, which is hopefully well designed, and then you break it into a suite of small services, each running its own process. The key to that is monolith should be well designed. If you have a big pile of monolith, you don't expect a spaghetti ball to be broken down into microservices. Don't expect that. But essentially, you break down a single application into a suite of small services where they're talking to each other using simple protocol like HTTP. And that's how they're communicating with each other. Each of the unit is independently deployable, and they do not require any administration or management. And then they could be coded using different programming languages. They could be using different storage technologies. So in that sense, it gives you the ability to use the right tool for the right job, as opposed to saying, hey, company-wide we use Java or Python or Ruby, whatever that language is. End of the day, HTTP is the protocol that you agree upon for these different applications to communicate with each other. Let's look at the definition now, and then we will revisit this definition towards the end, showcasing exactly the different components, how we talked about, how they solve it. Take a look at your classic web application. How do you design it? Well, you got a web page, you got a bunch of JavaScript, well, you got a bunch of web pages and one bunch of JavaScript. Each of those typically make a call to a REST endpoint. You don't care, you don't worry about where the REST endpoint is hosted. Then those REST endpoint essentially call a code. Could be in a Java EE application, Spring application, Node.js, wherever it is. You got those applications hosted. And then finally, it does a CRUD to the database. You may perform business logic, transactions, security. So this is a very, very extremely simplified definition of how your typical web application may look like. If you see from another perspective, it's basically an MVC kind of an architecture. You got your controller in the middle, which is your REST endpoint, which is defining where the request or the control should go to. The view is on the web page and the JavaScript part of it, and the model is sitting at the back. Okay? Again, a very overly simplistic view of how your application may look like. If you were to kind of break this down, how would you do that? So essentially, I could have multiple HTML pages, index, update, create, delete those HTML pages. My REST APIs are essentially get, put, post, delete. How you expose them, whether you're using Jersey or you're using Node.js, it doesn't really matter. In the back end, you could use, for example, a Lambda functions. We'll talk about Lambda functions. What does it mean, really? And then they could store to any database. In this case, I'm choosing Couchbase, but you can choose any database of your choice. Doesn't really matter. So the architecture that I'm going to show you here today is how your service, the static files, could be hosted on S3, how your APIs can be configured using API Gateway. Then Lambda is where your serverless architecture is going to sit, and then eventually your database could live wherever you want it to. In this case, it's Couchbase. So that's sort of the broader architecture. I'll talk about it. I'll show how these different services can independently evolve and communicate. Let's talk about serverless computing. There are certain typical challenges with server-based computing. What that means is, okay, I need a EC2 instance, or I need a VM, and I need to run a server for it. So, okay, how do you do the budget and performance comparison? Do you overcapacity it? Do you undercapacity it? How much money you got? So you go to do that capacity planning to begin with. How do you scale your servers up and down? Now, I'm not saying these are not known problems, but just to be aware of some challenges that comes as part of it. So these are challenges. but there are known solutions to this. What operating system? I want to run Tomcat. Should I be using CentOS? Should I be using Ubuntu? Should I be using RHEL? Is it my corporate license? Should I bring my own license? Do you really care about that? Okay, I got my operating system. What settings should I do it, which is optimal for Tomcat? Or should I use an ARMY, which is already pre-baked with all those settings? Operating system upgrades, how do I handle with that? Who should have access to servers? How do I deploy new code? So these are some of the challenges typically when you're doing a server-based computing that you need to be aware of and you need to deal with it. So let's take a look at it, how virtual machines, and then the next wave that we are seeing, containers, and then the future wave that we'll be seeing, which is sort of becoming prominent now, is serverless. Okay. If you take a look at it in terms of virtual machines, your unit of scale is you take one virtual machine and you replicate it if you want to scale it. In terms of containers, each container could be, or a bunch of containers could be an application, and then you can scale them. If you want to scale, then you're scaling really at an application level. In serverless, what the unit of scale is function. Think of it, an application as broken down into multiple functions, is an event-driven architecture in that sense, and that function is what is the unit at which you are scaling it. In terms of abstraction, when you're using virtual machine, you don't care about what is the underlying hardware. You say, I want 4 CPUs, 16 gig. You're running Intel, you're running NVIDIA, I don't care, just give me this processing power. In terms of containers, you don't care about what is the underlying operating system. Hey, I'm running a Docker container, whether you're running on Ubuntu or CentOS or Mac or Windows, just give me a Docker container and I'm good with that. In serverless, what you care about is the language. I want to run a Java function. Everything else, how you want to run it, how you want to provision it, how you want to scale it, is up to you. I don't worry about it. Then in terms of packaging, if you look at virtual machines, if you're running on Amazon, then your typical unit is ARMY, or Amazon Machine Image. In terms of containers, of course, you're taking your image or a Docker file where you pull the container definition, and then it packages an image and it goes into Docker Hub or container registry. In terms of serverless, your unit is really code. Hey, this is the code I want to execute. You go figure out where to run the code. What do you configure in each case? In AMI, in virtual machines, essentially, machine, network, storage, operating system, all that needs to be configured by you. You can use pre-configured AMI, or you can have somebody else bake the AMI for you. But in terms of containers, excuse me. In terms of containers, you need to run servers, configure applications, scale it, and all that thing that you're responsible for. So you need to run some sort of a monitoring dashboard for that. In terms of serverless, it's pretty straightforward. Here is the code, run it, scale it whenever it needs to be done. Execution, again, you can see sort of the different programming models, multi-threaded, multi-task, as opposed to serverless, which is single-threaded, single task. It's a single function running at a given point of time, non-reentrant, and you can deal with that. Lifetime, if you are looking at a virtual machine, they are typically running from hours to months. If you're looking at containers, typically they're minutes to days. You would typically recycle your containers from minutes to days. And last but not the least, in serverless, your serverless functions run from microseconds to seconds, and then you're done with it. Cost, if you look at it, typically your virtual machine is per VM per hour. If you look at containers, is per VM per hour as well, because essentially that's where your containers are running. In terms of serverless, it's down to the granular level, where you're saying per memory second per request. Okay, and I'll talk about AWS Lambda, which will compare and contrast these things. And last bullet here is in terms of offering. If you take a look at it, virtual machine, typically when people think about it, they call it as EC2. Is sort of my standard way of building machine images. If you are running containers, then of course you have different offerings, Docker, Kubernetes, or Amazon's EC2 container service. And then if you're doing serverless, then of course there is AWS Lambda, and there are some other vendors who have their serverless offerings as well. Another view in terms of, if we kind of flip the table a little bit, if I'm looking at infrastructure as a service, container as a service, platform as a service, and FaaS as opposed to calling it serverless, I prefer the term FaaS, which is functionless as a service or functions as a service, because essentially serverless kind of gives you an indication that there is no server in the background. It's just that you don't care about server in the background. So essentially to you, it is somebody is providing you function as a service. You say run a function, and it runs the function. How does it scale? What is the server in the background? What is the operating system? You don't care about it. So if you take a look at it in the yellow part of it, if I'm giving you a FaaS, I don't care about the runtime. I don't care about which JDK version, whether I'm using containers, not using containers, is upon me. What operating system, what virtualization, is it running on Google Cloud or Amazon Web Services? It doesn't really matter. So that's sort of the level of abstraction that you want to look at it. So if you think about FaaS, it really gives you that ability to focus only on the business logic that you care about. People typically get confused between, what is the difference between PaaS and serverless? So the point is, Adrian Cockcroft says, my boss, he says, if your PaaS can efficiently start instances in 20 milliseconds that run for half a second, then call it serverless. Typically, PaaS, as we saw, it has a little bit longer life, in terms of running time. But serverless is event-driven. Something happened, do something, and store the result somewhere else. And I'll show you some examples of that. So what is AWS Lambda? Well, AWS Lambda is Amazon Web Services offering for doing function as a service. It's fully managed in the sense there is no provisioning that is required to be done. It supports 4 languages, Java, Node, Python, and C#. What that means is you can write your business logic in these languages, and you can say, Lambda, run this. Of course, it defines the configuration that if you're using Node, here is a version that will be provisioned. If you're using Java, here's a version that will be provisioned, so on and so forth. But it takes care of compilation, building the class file, and running the whole thing for you. There is absolutely no administration, and it is very highly available. You can say at any point of time, I want to run 100,000 instances of this serverless function concurrently, and behind the scene, it'll scale automatically. AWS Lambda particularly uses LXC containers behind the scene, but that's just an implementation detail to you. From your perspective, you care about it. I want 100,000 concurrent execution of this serverless, and go do this for me. In terms of metering, it's charged for every 100 milliseconds of execute time. So that's sort of the unit at which you are charged. There is no charge for storage of the function by itself. And I did something here. OK. And finally, in terms of continuous scaling, you just store the function, and you execute it or invoke it as you want to. How does it need to scale? How does it need to monitor? All that is completely upon AWS Lambda. So that allows you to focus on your business logic. Here's a business logic that executes it. It's a little different way of thinking as opposed to like, here is my one class with 3 functions and another class with 3 functions. It's a more event-driven approach, and I'll show you a sample of that. So how does it work? For example, you upload your code to AWS Lambda. Of course, you can do that using AWS console, or you can take your Java code, package it as a zip file, and upload to AWS Lambda. I have a project which does that using Maven plugin as well. Then something needs to trigger that serverless, because it's either a click on a web page, or update in a DynamoDB table, or invoking using a REST API gateway. Something needs to say, OK, go invoke that Lambda function. Each Lambda function is given an Arun, or Amazon Resource Notifier, Amazon Resource Identification Number, and then it invokes that Lambda function. Lambda runs your code when triggered, using only the compute resources required, and you are charged based upon the execution time, literally down to 100 milliseconds execution time. And so you're really paying for the compute time that you use, no time for the storage. So how does AWS Lambda pricing work? Anybody can go to aws.amazon.com. You can sign up for a AWS account. The first 1 million requests per month are free. 1 million requests per month are free, which is pretty good to get started with. So if you are a small shop where you think that you're going to get up to 1 million requests for that serverless architecture, that is pretty golden. That's a very good way to start with. And essentially what you get is, depends how you calculate that 1 million requests. Essentially, what you get is 400,000 gigabit seconds of compute type per month. And then depending upon, I want 128 megabits of memory, or I want 1 gigabyte of memory, accordingly your calculate time or the compute time is calculated. Now remember, the thing is, you are only asking for, here is the compute time that I want. The CPU and the network are automatically allocated for you. So that's sort of, it's a very opinionated way of doing Lambda functions. Here is a function that I want to run, and I think it will take about half a gig of memory. You allocate the CPU and the network for me accordingly. So, and then once you expire the free tier, it's literally 20 cents per million requests thereafter. So literally, in a matter of a few dollars, you can deploy and build your entire application and host it on AWS Lambda. This is sort of what I was talking about. If you ask for, say, 128 megabytes of memory, then you can actually get 3.2 million requests free per month. If you go down here, if you're looking for, say, 384 megabyte or almost half a gigabyte of memory, then you're almost getting 1 million requests per month free. And that quota kind of goes over every month. What is the typical use case? So let's say you take an object. We talk about how Lambda functions are triggered. So let's say you take a photograph, you store that photograph in S3 bucket. As soon as it is stored in S3 bucket, that generates an event. That event can then trigger a Lambda function. That Lambda function can then say, hey, you know what? This is a full-blown 10 megabyte image, and I'm going to take that 10 megabyte image, and I'm going to start creating a different thumbnail depending upon the device sizes. So I know, for example, this image could be viewed on 5 different form factors, and I'm going to create 5 different images for it automatically. That serverless function is going to do that, and I'm going to store it back into the S3 image. By the way, this is a use case that's how Seattle Times, back in the US, use this exactly use case on how they use serverless architecture. So Seattle Times, if you want to read it in a different form factor, image is stored and it automatically generates for you. Another example, very classic web application, for example, an online order is placed, as soon as the order data is stored into DynamoDB table, that then triggers a Lambda. So any update into DynamoDB could trigger a Lambda function for you. That Lambda function can then extract the data, run the transformation code, and load it into a Redshift data warehouse. And then analytics could be generated from that data. So you can start chaining your serverless functions to do the right thing and then store the data into the right source. Another one, this is rather a more classic web application. You want to do a front-end code, which is hosted in S3. S3 has the capability by which you can host a static website. So your front-end code is hosted on S3. As soon as you click on the link, it goes using API Gateway. API Gateway we'll talk about in a second, but it can be configured for your REST front-end. The REST front-end says, okay, it's configured as soon as you invoke HTTP GET, it's going to go and call a serverless function, and then that serverless function is going to query from DynamoDB and return the result back to you. So this is a very classical web application that can be designed instead of using your Spring or whatever Java EE, using serverless. So what are the key components of AWS Lambda? Well, I'm a Java guy, so here is a Java function which is your hello world of Java, for serverless. So I'm having public class hello world. Each Lambda function has to extend or implement this interface request handler. This is the Java syntax, but there is similar syntax for other languages as well. I'm saying, okay, give me a request, and I'm going to return the response back as well. So as part of this, you need to override the method handle request. So in the request is where you get the data passed to the function, like parameters that comes to you, like JSON data, etc., that comes to you. And then in the context, you get some of the runtime aspect of it, where you can operate upon it and then return the result back if you need to. So that's sort of a very simplistic way of saying how each Lambda function will look like. So essentially, your public class override public this would look the same. These request and response are my POJOs, the way I've designed them, because I expect my data to come in a certain format and the response to go back in a certain format, but you're free to use whatever format works for you. And context is what gives me more detail about Lambda runtime in case I want to get the request ID and the time, etc., and some things like that. So how does my first Java plus Lambda would look like? Well, first thing is, in a standard Maven project, I will add the Maven coordinates because I need the Lambda Lambda API. So I will include this Maven coordinates dependency essentially in my POM XML. Once I do that, I'm going to write my Java function or my simple Java project, and it gives me the ability to implement that interface. Then I'm going to use the AWS CLI to create a function. All I'm saying is AWS Lambda is a top level function, then create function is a sub function, so to say, and I'm giving the function name, I'm giving it the role. This is the role in AWS IAM. Then I'm giving it a handler. Handler is, you may have packaged a bunch of classes in your function. You need to identify one class as a handler, which is sort of the entry into the function. Then you say, okay, here is a zip file. Now, essentially, once you have created a jar file, you need to package it into as a jar. Well, once you have the jar file here, essentially, all I'm saying is I'm using a binary file protocol and referring to this as a zip file. This zip file is sort of my entry point to the function. Then I'm saying description. I'm saying runtime is Java 8. I don't care 131, 121, what patch are you using? I just care about Java 8. So you just say that. Then you specify the region, then timeout, memory size, and publish. So if you give this command, essentially, this will take your existing jar file and run it up there. This is actually published as an example on my GitHub repo, Arun-Gupta/serverless. So feel free to take a look at it. And then last but not the least, I can just say, hey, I want to test it. So I'm going to AWS Lambda invoke. This is the name I gave, hello world. So I'm going to say function name hello world. I specify the region. Region could be left. Now, if there is a default region already set, you need to look at it, which region the Lambda function is available at. And then I'm saying payload. This is the payload where I'm going, first name is John, last name is Smith. And that's the payload that get converted to my request POJO. And it says, hey, here's a JSON payload. Just map it to this POJO. And now in the POJO, I can access it. And I'm saying just dump the output into hello world.out. So it's a very simple and easy way to get started with Lambda functions. And you can invoke 1 million of these now in your, 500,000 of these because I'm using 1 GB of memory. So what I did is, for my microservice, essentially, I created a whole bunch of Lambda functions. I have a microservice post, get all, get hello with name. Well, these are my test ones. But essentially, in my microservice, all I wanted to do was get the list of all the elements from the database and then create a new one. So all I did was just created 2 functions. And you can see there are Java 8 runtime, and they were created a while ago. All right, so that's sort of my quick primer of how would you create your function over here. Now, Couchbase is a NoSQL document database. That's where I used to work earlier. Now, in terms of the database, it has a lot of capabilities. It gives you full data capability. Of course, you can store documents over there, JSON documents. It gives you the querying capability, where you can run SQL queries on your document database. It gives you all sorts of indexing capability. You can do the replication across data centers. It also has a Couchbase mobile, which allows you to very easily synchronize with the backend database. So I would encourage go talk to the Couchbase folks at the booth if they haven't shut down yet. You have search and analytics, all kind of capabilities that exist in the Couchbase database. So I showed you a simple Java plus Lambda use case. Let's evolve upon that. Let's take a look at it, how Java plus Lambda plus Couchbase would look like. Okay, very similar actually. One more animation, sorry. This is the same slide. So the key thing that I'm going to do here is, so here is my serverless directory. So if you go to my GitHub repo, Arun-Gupta, serverless, that's where my code lives. In there I have a AWS directory, then I have a hello Couchbase directory. That's where all my code lives for this Java plus Lambda plus Couchbase. And here is my jar file that is generated out of it. Now the key part, I could host my Couchbase or my database wherever I want to. In this case, the only thing that matters is I'm passing an environment variable where I'm saying Couchbase host this is where the EC2 instance is running. So on this host is where I'm gonna have Couchbase available. So once I have the host information available to me, I can use that in my application and then say, hey, go connect to this host and do whatever database operations need to be done. So pretty much everything that we have been doing so far, but just with a little bit nuance from serverless perspective. Let me see if I have internet connection here. I can show you here some stuff. I haven't even booted my laptop to connect here. What is the password here? Cannot be found to store, whatever, come on. Oh, okay, it connected, good. So if you look here now, here is my AWS, and here is my hello Couchbase, and hello Couchbase here, and here is hello Couchbase here, and here is my Java file, and if I look at hello Couchbase Lambda here, okay, so this is my hello Couchbase Lambda, implements request handler, request, and as I said, your request and response beans are really what you care about it. I'm using a handle request method here, where I'm saying give me the request, and in this case, all I'm doing is, well, this particular example, what I did was, I was receiving the request from an IoT button. So I ordered a whole bunch of AWS IoT button. Every time I will click on an IoT button, it will trigger a Lambda function. So essentially what I'm doing is, I'm saying, okay, from the context runtime, give me the request ID and the timestamp, and I'm gonna create a button document. Button document is a JSON document basically, and that document will then be stored into a Couchbase instance. So essentially, every time I click on an AWS IoT button, it's gonna generate a backend JSON document in my serverless function, and it's gonna persist that document into Couchbase. So right here where I'm saying, get the bucket, upsert into using a JSON document. And if you scroll down here on line 40, where I'm saying, oh, by the way, from the system, get the environment variable Couchbase host, which is how I'm configuring it to talk to my database. Well, this is the third example that I wanted to talk about. So here I'm saying, every time I click on AWS IoT button, it triggers the Lambda function, it talks using the Java SDK, and persists the data into Couchbase. All right, so one of the key things here is AWS IoT button, in order to talk to Lambda function, well, that's one of the events that, one of the ways by which it can be triggered. But if need be, in order to replace my IoT button with a web application, I need an API gateway, because the web application will eventually need to call a HTTP get put post delete, and that's what needs to trigger sort of my backend server function. That's where AWS API Gateway comes in. So what does it give? AWS API Gateway is, once again, just like any AWS service, is a managed service here. It gives you the ability to create, publish, monitor, maintain your REST APIs. Think of your Java EE application. If you are building a Java EE or a Spring Boot application, you annotate your functions accordingly, and it's all mixed up with your business logic. API Gateway is useful when you don't want to mix your APIs, what APIs are exposed as what functions. So essentially, you have your business logic, and then you start mapping, hey, here are my REST API. So you centralize all of your APIs at one point of it, because then you can start doing things like monitoring, metering. Then you can start charging your clients based upon API usage. Then you can start doing centralized API administration. So lots of benefits on why API Gateway is useful. You can manage multiple stages and version. So you can say, here is my test version, here is my dev version. Now I'm releasing a new API, and how I'm going to do the consolidation across different APIs. The AWS API Gateway particularly is also integrated with CloudWatch. So as you are invoking your APIs on the API Gateway, and as they are invoking the backend function, all of that you can watch, and you can see the logging of that into CloudWatch. Just like Lambda functions, you only pay for the calls made to APIs and the data that transfers out as part of the API itself. Okay, so some other aspects, you can start setting throttling rules. So for example, to prevent denial of service, you can say do not have more than 1,000 concurrent calls if you're going to this backend. So you can create really sophisticated rules if you're using API Gateway, which would not be possible if your API and your business logic code is mixed up into one tarball. Particularly in the AWS infrastructure, with using API Gateway, you can start getting integrated with AWS IAM. So you can have your identity and access management integrated with it. Or you can also integrate with AWS Cognito, which gives you full mobile security front end. It's a mobile backend as a service where you can say, do my mobile authentication using AWS Cognito. So all of that integration is very seamless. Another advantage of SDK API Gateway is once your APIs are configured, it gives you a simple JavaScript, iOS, and Android client by which you can easily embed those into your mobile phone or your web application and invoke those REST APIs. So how does the flow look like if you have API Gateway? You could have a variety of clients essentially that you want to invoke over the internet. The internet, of course, it goes to the API Gateway, which is where your REST APIs are hosted. Now, if you can optionally configure a API Gateway cache, so that if the results are available in the cache, you can return it right from there itself. If not there, then of course you can invoke any of the backends over here, whether it's EC2, Lambda, or some publicly accessible endpoint on EC2 or somewhere else. And then, of course, it's integrated with the CloudWatch monitoring as well. So with API Gateway, in that sense, you get a full-blown application which gives you the ability to not only do security and throttling and metering and management, but also a full-blown function which keeps your API logic and the business logic completely separate, and they can scale at different levels. In my case, what I wanted to do was build a simple microservice, and that microservice I wanted to just say, hey, it's a books microservice, and in the books I want to get the list of all the books, and I want to create a new book. So all I did is, this is a snapshot from the console. So essentially, at the top, what you can see is I'm creating a new book, new API, and new API is book, and exposed at /books, and in /books, I got a get and a post method, and you can see with get there is no authorization required, but in post as well there is no authorization required. But if need be, I could start integrating with AWS IAM roles. Then, as you are getting in, as you're invoking the API, you would be required to be in that particular role. So so let's say if you're coming in from a web application, then somehow you will have to pass the security context which goes through to the API, and then so that you're authorized to invoke it. So then, what I wanted to do was I wanted to build. This is a sort of basically getting towards my application. I have a client here, a simple web client. The client will talk to API Gateway, which is where all my API management is done. As soon as you click on the API, each API is configured to invoke a Lambda function. So book list and book create are my two Lambda functions, which are going to get invoked. And then my Couchbase instance is hosted on the EC2 backend. So that's sort of the broader architecture on how I expected this entire application to work. So let me walk through this one, actually. So if you look at this here, same diagram, but essentially the client could be curl or Postman or any web application here. And the slides, by the way, are available on the same repo that I talked about earlier, and it gives you the complete source code for it here as well. So if you scroll down, the first thing that you're going to do is create an IAM role, because essentially you do want this service to operate in an IAM role. So it kind of gives you exactly how will you create the IAM role. Okay, and here is the trust policy, how it's going to look like. Then you will create the Lambda function, and it gives you the source code for the Lambda function, and it gives you the AWS CLI by which you will create those zip bundles that we talked about. So this is the repo. So serverless AWS Microservice is a repo, and we can actually look at the source code as well. So if I look at this here, here's a simple book Pojo, and all I'm doing is I'm saying, okay, how do you convert back and forth, if I can speak it correctly, to JSON. Now I have all of my different methods here. These are my serverless functions. So I'm saying book delete, it gives me a book, and this is how I return the result. And behind the scene, what I do is I am invoking Couchbase util, and I'm saying, okay, from the database, go ahead, remove this object. If I go back here, if I look at Couchbase util is again reading the value from Couchbase host. And in this case, I'm using system get property and get env, because get env is useful for the Lambda function, and system get property gives me the ability to invoke it from the command line as well, like a Maven project. And then I'm just getting the bucket, and I'm performing the functions on it. Okay. If I do get all, so pretty much similar logic here. All I'm saying is from the Couchbase util, give me the bucket name, run the select star query on it, and limit it only to 10 documents. So I can very easily invoke this, how I'm coding my entire business logic. Now, one of the things that you need to understand is I had to build, in order to particularly integrate with API Gateway, I had to build an additional serialization layer, because the way essentially what's happening is your web page makes a request to API Gateway, then the API Gateway makes a request to the backend serverless function. Their protocol on what kind of data do they expect between each other is a bit different. So essentially what I'm doing is here is, if you look at this, Couchbase is a package where all my Pojos are living. So bucket get one, just get me one book from the bucket. But the moment I'm going through, so this gives me the ability where I can invoke the serverless function directly. But the moment I'm going through gateway, it's a different serialization protocol. So in this case, I have, if you look, say, bucket get one, bucket post, let's say. If I look at bucket get post here, so then you can look at it, it's using gateway request and gateway response. And those are my classes that I have created here. So if we look at gateway request here, it does serialization in a slightly different way. It expects data coming in, inbound, and outbound to be in a certain format. So I had to write those serializers, and that is one area which it could be slightly improved here, in my opinion. But the important part to understand here is, if you are communicating directly to serverless, there is standard serialization protocol. But if you're going via gateway, then the protocol is different because the format is different. So what is your typical development workflow when you're building your service like this? The typical development workflow would be, you will implement your business logic. Of course, it's all event driven. That now the way we were thinking about it, whether app index HTML, click on it, go to API Gateway, get the data from DynamoDB, and return the result back. So you write all of your events. You write your HTML pages. You deploy the Lambda function. You create or update and deploy the REST API, which goes through API Gateway. Then you need to connect your API Gateway to the Lambda function. And that can be very easily done using the console itself. That, okay, the moment I click on this API, it needs to invoke a Lambda function. Then, of course, it invokes the API. You test and debug, and you repeat the cycle until it gives you the functionality that is really required from the application. take it a notch higher. I mean, I'm doing too many things here, and I'm creating a module. I'm creating a zip jar file first of all. Then I'm uploading it to the AWS Lambda. Then I'm saying, okay, here is my API gateway. Here is how you connect all of them. So that's exactly where the serverless application model comes in. This is again an effort by AWS to define a standard way of building serverless application. If you're familiar with AWS CloudFormation, it basically extends that. Now, CloudFormation is useful if you were to manipulate multiple resources. So for example, let's say for your application that is running exclusively on AWS, you want to create certain EC2 instance, you want to install a database server, you want to install an application server, you want to create some IAM roles, you want to configure those roles. Instead of writing a script, what you will do is you'll create a CloudFormation template, and it'll do everything for you. It'll coordinate all of that for you. So what does SAM do? SAM basically extends CloudFormation template, and it adds new resource types over there. So it says serverless function, serverless API, and serverless simple table. So now everything that I've done so far for building my microservice, let's see how I can simplify this very easily using serverless application model. Okay. Again, this code is available on my GitHub repo. So if you look at this here, on the top where I'm saying this is a serverless application model from 2016 1031. That's when the first version was announced. And here I'm saying, okay, here is a microservice get all. I'm basically defining a serverless function here. The type is just a standard function, and I'm giving it a handler here. I'm giving it a runtime. Now, in order for serverless application model to work, the jar file must be uploaded into S3. So this is where I uploaded the jar file. Then I'm defining other variables, other properties here. And then finally, I'm saying Couchbase host is living here. And then the IAM role. So instead of using that cryptic AWS CLI, which some of you may find challenging, just put this into a configuration file. And then you say AWS CloudFormation deploy using this particular SAM file. And that's it. It'll create the function for you. It'll create the API for you. Well, in this case, not, because in this case, it'll just upload the function. But let me show you another example. In this case, it will create an API for you. So for example, if you look at line 30, it still says this is a function. On line 32, I'm still specifying the handler, runtime, code, timeout, all of those. But if you come down here, all I'm saying is, what is going to trigger this serverless function? And that's defined in the events. So I'm saying every time a get resource is called, so create an API, here are the properties, here is the method. So you can start defining all of this model very cleanly using serverless application model in just one YAML file. So essentially what will happen is you will create one serverless application model .yaml, and then you will have your code created and uploaded to S3 bucket, and that's about it. Using this SAM file and using AWS CLI, you can create not only your serverless function, your API, but link them together as well. All right, last bit of piece. So what is AWS S3 Basics? I won't dig too much into it, but essentially it's a simple way by which you can store exabytes of data, any amount of data that you want on Amazon. Now, these are some of the properties for it. It gives you 11 nines of durability. It has all sorts of access control, authentication, etc. But what are the key AWS S3 concepts, and why is even S3 relevant here? Well, AWS S3 has buckets. Buckets have object, and object has metadata and data. So that's sort of the very high-level definition here. Now, in metadata, you have a key and you have a version of the data. So that allows you to store multiple versions of the data in there. The key part here is what defines the data uniquely: a bucket, a key, and a version. There's a bunch of other metadata, but these three things are what define the data very uniquely. So now what I can do is, on S3, I can create a simple S3 bucket. The key part to look here is the static website hosting. By default, it is disabled, but I can enable this. And what that means is, because S3 is across regions, across multiple availability zones, it truly serves as your CDN. So my static website could live on S3, and then I can say, hey, I want to invoke my application. I've enabled static website hosting. It is running a backend web server. Just serve my request. Now this S3, so once I enable static websites on S3, I can just say, use this web bucket to host a website. I can say what is my primary document, what is my error document, and I can start configuring those rules. So here is sort of my deployment architecture, how it would look like. So if you look at this, my client, if I'm calling a simple REST API, then it'll go to the API gateway. This client could, by the way, still, this is my client. So if I'm calling a simple REST API, it'll go to the API gateway, get, post, delete. Each of those have a corresponding serverless function. Then they can talk to any database sitting on your EC2. Or if they're calling a static page, which could then redirect to the API gateway, that could go to CloudFront, which is basically your CDN, so that the page is served instantly in your zone. Then you can have your domain name server here, and then this could go to your S3 bucket. So essentially, with your S3 bucket hosting your HTML and JavaScript code, with your second level being API gateway, the third level being your serverless, and then the fourth level being your database living anywhere on AWS, is sort of what gives you a complete microservice deployment architecture. Let's revisit this definition once again. We talked about a suite of small services, each running in its own process. That's exactly what our Lambda functions gives us. They're independently deployable because each Lambda function can be independently deployable. There is no management required for them because all you say is, here is a function, upload it, and AWS will take care of managing this for you. AWS Lambda functions, once again, gives you different programming languages. Today it gives you Java, Python, C#, and Node, and more languages going to be added in the future. And then similarly, it doesn't matter where your data storage technology is. This sample I'm using Couchbase, but you can use, for example, a relational database service, which gives you 6 different databases running on Amazon. So like Oracle, Aurora, MySQL, Postgres, all of those database services are available, which are managed service on AWS. So you don't have to really worry about where the database is running. And that's pretty much a wrap. All the slides and the code are available on this URL. And anything, of course, about Amazon is Amazon Web Services at aws.amazon.com. That's a wrap, I think. I'm going to take questions off the mic. Thank you.